Welcome to Homework Lib.
In this question, we are going to draw the energy diagram for a two-step reaction where the second step of the reaction is faster than the first step of the reaction. So now let's recall the definition of Gibbs free energy change. And that is the difference between the free energy of the products minus the free energy of the reactants. Okay, so if the Gibbs free energy change is negative, then the free energy of the products is less than the free energy of the reactants. Okay. Therefore, the reaction is exergonic, and that means that the forward reaction is energetically favorable and the reaction occurs spontaneously. Since it occurs with the release of heat. Okay, also seeing that it is a two-step reaction where the first step is slower than the second. So we have a two-step reaction. Right? So if the second step is faster, that means that the activation energy of the second step is less than the activation energy of the first step. Okay, so now let's represent that in an energy diagram. Okay, so we have two steps that we need to account for. So now let's just start off with the reactants. Okay, now let's draw the first step of the reaction. Okay, so the highest energy structure of the reaction would be the transition state. So this is the first transition state. Okay, and here we have the intermediate. Okay, And let's draw in the first activation energy. Okay, so that's the first activation energy. And now let's proceed with the second step. And let's recall that the second step is faster than the first step, so it has a smaller activation energy. So here we have the products. Okay, here is the second transition state. Okay, and the energy difference between the intermediate and the second transition states. You'll have the second activation energy, which is smaller than the first activation energy. Okay, now finally, let's draw the free energy change for the reaction. Here, the free energy of the products is less than the free energy of the reactant. So this is the energy profile diagram.